let's do it, right? Yeah, it's only 2 days this week. It's a nice little refresh before we get started again. All right. And this stuff we're doing here is all right. Yo, here we go. We're getting started. What are you saying, Baker? All right. All right, Unit 8, right? Our last unit of the semester, solving systems. A lot of this unit, guys, I just mentioned to you, it's going to be a review. You've done a lot of this stuff already in Algebra 1. Should be pretty simple. So we're talking about solving systems of equations, 2 or more equations of variables. Talking about a different variety of ways to do that. We're talking about 3 different ways to do it today. All of which are a review. We're talking about real-world problems. And then we're talking about linear programming a little bit. So first of all, what is a system? It's that question on your paper right there. A system is 2 or more equations of the same variable. So we have an example on the board for you, right? We have 2 equations. They have the exact same variables. They both have x, they both have y. Anytime we give you a system in this unit, they must have the same variables. They will. We're not going to give you a system that doesn't. So to solve one of those systems, we're going to find the values that satisfy all of the equations. If you find a solution for this top line here, this top equation, but it doesn't work for the bottom equation, that is not a solution for our set or our system. It needs to satisfy both of the equations at all times. And then our last thing, this note here that there's not really a spot for it here, but I'd probably make sure I write it down somewhere. All of your answers need to be written as an ordered pair. Right? Unless we're talking about those real world problems we're talking about later in the unit, where we're having you like write a sentence that makes sense about what could be an answer. It's going to be written as an ordered pair, right? Just like you'd write 2, 3, put parentheses around it. You'd write -2, -4, put parentheses around it. All of our answers will be written as an ordered pair. If you write x equals 2, y equals -6, it's going to get marked wrong. It's an ordered pair. Right? I'm going to be kind of a stickler about that this unit. We all got that stuff down? Yeah. We're good? Cool if I keep moving or I need to wait a second? You're good. Speak now for hold your peace. Moving. Alright. So, first, before we start our stuff, let's just review how we graph a line. Right, so we're going to need it in a second. Y equals 3x minus 2, right? Y equals mx plus b. In this case, if I have y equals mx plus b, oh, that's way off. Give me 2 seconds.
Yeah, we need to review this.
Alright, so y equals mx plus b. What does b stand for?
Y-intercept.
Y-intercept. So in this case, my y-intercept is going to be at
-2.
Put a point at where y is -2, right on the axis. Okay? What does the m stand for?
The slope.
Slope, right? So m is the slope. So right now it's 3 or 3 over 1. Up, 1, 2, 3, over 1. Remember, slope is always rise over run. 1, 2, 3, over 1. And you would take your straight edge out and draw your line. Now guys, like in the last unit, I really don't care what you do in your notes. If you don't use a straight edge, if on your notes, on your homework, I don't care. Right? It's your notes, your stuff. Now, when we start getting to the test, you need to use a straight edge on problems. And we'll see why in a second. Alright? We're going to end up graphing 2 lines on the same graph. We're going to see where they intersect. And if your lines aren't straight, think they're going to intersect at the right point? Probably not. So make sure you have a straight edge. If you don't have one on test day, let me know. I have plenty of them for you to use. Okay? Like I said, notes, do whatever. Tests, you need a straight edge. Okay. Second one here. 2x minus 4y equals 8. Standard form. How do I graph that?
You need to
Change it into y equals mx plus b. You could also do the cover-up method. I'm not going to do the cover-up method. Right? If you want to do it, you can. Change it to y equals mx plus b, so subtract 2x. -4y equals -2x plus 8. Wonderful. Divide by -4 on both sides. We should get y equals -2 over -4 becomes 1/2 x. 8 over -4 becomes -2. So I have it equal to a positive y. Now I go ahead and graph it, right? My b value, -2, my y-intercept. Put a point at -2. I have a slope of 1 over 2. Up 1 over 2. Up 1 over 2. And like I said, take a straight edge out. Draw your line. Alright, wonderful. Any questions on that? Okay. If not, then let's do our graphing portion of this, right? It's going to be really easy. So, if I'm graphing a system of equations so I can solve it, I'm going to graph all the systems, or excuse me, all the equations in my system on the same coordinate plane. So in this case, we're just going to have two of them. So graph both equations on the same coordinate plane. Locate their point of intersection. Guys, why do we want to know where they intersect?
In the middle.
Well, yeah, they're going to intersect somewhere in there, right in the middle. But why do I want to know that? Why do I care where they intersect? Think about it. All the points on this line, guys, they're all solutions for this equation, right? Any point I pick off my line is going to make that a true statement. Okay? Well, any point I pick off of this line is going to make that a true statement. Remember, we want the point that makes both of them true. So where they intersect is where it's going to be on both of our lines, right? So our point of intersection is going to be our solution for our system. So if we look here, we look at our first set of equations. Y equals 4x minus 1 and 3x plus y equals 6. We're going to graph both of them one at a time. Y equals 4x minus 1. What's my y-intercept here? Negative 1. Be very careful. Right? Negative 1. What is my slope?
4x.
4 over 1. Or you could say 4x, right? But it's 4 over 1. So rise 4, run 1. Rise 4, run 1. 1, 2, 3, 4. 1, 2, 3, 4. And plot our line. Like I said, guys, if you're not using a straight edge, there may come a time where you don't draw a straight line and your intersection points can be off a little bit. It's going to get marked wrong, right? So if you're using a straight edge, it should work. Alright, second one here. I got to get it so it says y equals. So I'm going to subtract 3x. Y equals negative 3x plus 6. Willie, question? You good? Okay. Alright. Y-intercept is at 6. Positive 6, right? It's this b value at the end. So 1, 2, 3, 4, 5, 6. And my slope is? Negative 3 over 1. So down 1, 2, 3 over 1. 1, 2, 3 over 1. Draw my line in. And it intersects right at that point. Now, I circle my point of intersection. Do you have to circle it? No. I'm not going to mark it wrong. That'd be kind of silly of me. But what point is that?
The intersection point.
Yep. So it's at 1, 1, 2, 3. So I write it as an ordered pair. 1, comma, 3. Make sure you put parentheses around it and circle it. Cool? Any questions? Nothing? Flip it over, there's another one. You guys go ahead and try it. I'll do it on the board as you do it on your paper. You're more than welcome to ask any questions you have. Hey guys, you trying a problem over there?
Yeah, I'm doing.
Alright. I'm just checking.
For one half, would you just go down 1 over 2?
Perfect.
To the right, right?
You go to the right too, yeah. Remember, if you go down to the left, that'd be like a negative over a negative, which would be a positive.
Okay.
Right?
I don't know.
If you get with a negative y,
Yeah, whatever
just
we get.
divide by negative 1.
Right, because we want a positive y, like y equals mx plus b is going to be positive.
Got it.
Smell what we're stepping in? I didn't say it was you.
So 4x. Is the horizontal question first?
Yes, sir.
Do you write it when it goes horizontal first?
What's up?
So it goes 4 to
You got 3 coming
Yeah, so
forward.
like 4, so whichever, like left and right goes first, and then up, down, goes
Wait,
up.
would it be 3, 4, or 4, 3?
It'd be 4, 3, right, 'cause we move over 4, we don't up 3.
Boom!
Any questions? Good?
I'm just looking at
You got a pencil? You got your pencil? Ask that ahead of time, man, come on.
Guess what? We don't know which one is which.
There you go, sir.
How do you have no night?
You're welcome. Well, how are you doing? Questions? Alright guys, hey, check your answer line on the board, please. Shh. Yo. Hey. Remember, I saw a couple people, if we get a negative y, we just multiply or divide by negative 1 on both sides, and we get a positive y value. We get y equals 3x minus 9, you can graph it. Should have got 4, 3. We good?
Yep.
You guys got any questions?
Nope.
Alright, we're going to do 2 different ways of solving with algebra. First way is going to be called equivalent forms. So guys, on the test, we're not going to tell you, hey, you should probably use equivalent forms for this one, or hey, you should use substitution for this one. You are going to have to decide on your own which method to use. The only one we'll tell you to use is the graphing. Right? If on the test you want to do all of them graphing, let me know. I'll get you more graph paper. Right? If on the test you want to do them all equivalent forms, make it so you can do them all equivalent forms. If you like the substitution that we're going to do after this, do them all substitution, right? Find what you like and use it. Now, in each situation, one form's be better, or quicker, I should say, than the others. You can use them all, just one's usually quicker. So equivalent forms. That's talking about when things are equal, right? Equivalent means equal. Well, equivalent forms are going to happen when we have things that are equal to the same variable. Right? In this case, they're both equal to y. Right? What that's telling me is if 4x plus 5 equals y, and 3x minus 7 equals y, both of these things need to equal each other. Right? If they equal the same thing, they should probably equal each other. So what I can do is I can take each of those pieces, 4x plus 5 and 3x minus 7, and I'm going to set them equal to each other, right? If they equal the same thing, I'm going to set them equal to each other. Well, now I only have one variable to deal with. I'm going to solve for that variable. I'm going to solve for x. So I'm going to subtract 3x from both sides. I get 1x plus 5 equals negative 7. That was a really bad 7. What do you say? Minus 5. Perfect. I get x equals negative 12, right? Well, what do you think I should do with that negative 12 then? Because I don't want just an x value.
Put it in x.
Put it in for x in either of the equations. Doesn't matter which one you use. You can use top, you can use bottom. Jackson, would you like to use the top equation or the bottom equation?
Bottom.
The bottom, perfect. Like I said, it doesn't matter which one you use. Y equals 3 times negative 12 minus 7. 3 times negative 12 gives me negative 36. Minus 7.
Negative 29. Or 29.
Careful.
Oh, no.
Negative 43, right? We're subtracting off a negative. Very careful. So y is negative 43. Sweet. So I just put a box around x, put a box around y, call it a day?
Yeah.
Why not, Bryce?
Because isn't a negative?
Check your solution to both equations.
Or no, they have to be they have to equal the same thing, right?
Write the solution to ordered pair.
Right? Your solution is an ordered pair.
For the top.
Yep. So guys, hey, shh. Just like we did it when we were graphing, we're writing our solution as an ordered pair. We said that at the start of the day. Every answer is going to be written as an ordered pair. So I'm going to write it as negative 12, negative 43. Now, the really cool part about this unit is you can check every single one of your answers. Right? You can take what you got for an answer, you should be able to plug it into both equations, and it should make a true statement for both equations. Right? If I check it down here, we did all the work already, I get a true statement. If you don't get a true statement for both equations, something went wrong. Right? You got to go back, check your work, see what you did wrong. You should always get true statements for both equations. Now, am I going to require you to check your answers? No. It's really up to you. But if you have the time on a test, plug that stuff back in. Double check you got them right. Sweet. There's a second problem for equivalent forms on your paper. Please go ahead and try that one. I'll do it on the board as you do it on your paper.
Wait, which one are we doing? Are we doing this one? I thought we were doing the bottom one.
No, not yet.
That's what I got.
Turn into 3x, right? Add x. Turned into 3x if you add x, right?
Yeah.
You sure?
You should be able to put it in either one. You should the same thing out. So you put it into this one, right?
You got negative 2.
Oh, sorry, negative 4.
Plus 5.
Oh, then you put a negative 2 for negative 4 plus 5, negative 1.
So our answer
Negative 2
should be
and
negative 2.
Wait.
Whichever you put, we got one out of both.
Oh, yeah, I'm
We want to accidentally
I
do
didn't
that.
Keep the chopstick because I'm not trying to do the window.
How'd you guys do?
I didn't give you that hand, the nose, you like really like yelled at me.
What's up, dude?
I keep a chopstick because I'm not.
Alright, hey guys.
About a conspiracy. I said, well, like, not like you
Hey, don't need to mock people though. Don't need to do that.
You got the whole squad line.
I had
Guys, hey, relax. Do I need to go through this at all? Did you check your work with mine?
Yes, I did.
We got any questions? Can't get them out of my mouth right now. Words are hard. So, should have got negative 2, 1. No questions? 2 problems left. That's it. Next one, we're going to talk about substitution. So, equivalent forms was good when they were both equal to the same thing, right? Substitution is going to be good when we have one of our equations equal to a variable. Well, in this case, 3x minus 5 is equal to y. We're going to use substitution to help us solve for one of our variables. So what I'm going to do, hey guys, what is 3x minus 5 equal to?
0.
What's it equal to? Y. So what I'm going to do in my other equation, I am going to substitute 3x minus 5 in for y. Right? Just like you would if I said y equals 3. Or like in this problem back here, we said x equals negative 2. We plug that in for x, one of our equations. We're doing the same thing with 3x minus 5. We're just plugging it in for y so we can solve for x. So it becomes 2x plus 5 times, and instead of y, it's now 3x minus 5 equals negative 8.
I know.
Does that step make sense?
Mm-hmm.
Right? Because it equals y, I can replace y with it. Okay? Yes?
Yep.
No.
Yeah.
Yes? Okay. Alright, then we're just going to solve for x. Distribute our 5. 2x plus 15x minus 25 equals negative 8. Well, 2x plus 15x is 17x minus 25 equals negative 8. So, add 25. Add 25. 17x equals 17. Then divide by 17, you get x equals 1. Sweet. We got what x equals. We solved for x. Well, Aiden, what do you think I should do with that x value that I just got?
Put it into one of the ones and figure out what y equals.
Put it into one of the ones. Into one of the equations, right? Either equation. Take that x equals 1, plug it into either of your two equations, solve for y. Isaiah. Which equation? No, no, this is Isaiah. Which equation would you like to use?
Second one.
The second one. 2x plus 5y equals negative 8. I'm going to plug 1 in for x. 2 times 1 plus 5y equals negative 8. 2 times 1 is 2 plus 5y equals negative 8.
Minus 2 on both sides.
Minus 2. We get 5y is negative 10.
Y equals negative 2.
Divide by 5. Y equals negative 2. Baker, is that a good way to write my answer?
No.
How should I write it?
Parentheses.
What?
1, negative.
Good. In an ordered pair. Very good. So, guys, like I said, whatever variable it's equal to, it might not be y. It might be x, right? Whatever it's equal to, plug it in the other equation. Solve for that variable you're left with. You get x equals 1. Plug that into either of the two equations at the beginning, and you get your opposite variable. You get y equals negative 2 then. Write it as an ordered pair. Check your answers if you'd like. Any questions about substitution?
Nope.
All right, then. Try the second one, please.
I don't like this method. Wait, do we have to use this method on the...
You do not have to
I
use this
do
method.
not like it. I don't
I'll
like
talk
it.
about that in 2 seconds.
I like
I don't like this method.
the equivalent form.
I like the first one.
Guys, if you have questions, let me know. I'm more than happy to answer them. We'll talk in about 30 to 45 seconds about this problem, and then get your homework.
Brett had work.
No.
Yeah.
What time did you go to work? Damn.
Hey,
Who takes it?
Football.
He works at it.
I know I did that.
You need to get his car fixed.
So I was going to grab it. And then I thought, so I dropped the
Actually, no, it is.
I'm guessing it's probably the one he gets from the next paycheck. I'm guessing it's probably
You word it to me.
You see Alex yet? You did see her? Alright.
I know what you just
I
did.
didn't just see her.
Graduate.
It's huge.
That you believe that.
Did he talk to Bennett?
Really,
Who are they?
about this one is that if you don't put, you can't use both. You can't use them on the left.
No, I don't know that.
Alicia,
What do you see up there? Where's that G? Under smoke, like there's a certain letters underneath, right? So if you know the G, so go, which direction? G, go, so go up, and
January 9th is when they start.
alright guys, hey, so, like in this problem, our variable is equal to x. So I'm gonna take 2y plus 12, plug it in for x. Solve it out, I get y equals -5. Take -5, plug it into either of the original equations, so you can get your x value of 2. So you get 2 -5. Now, I ran through that super quick. Does anyone want me to go more in depth on that? Do we have any questions on this problem?
Go more in depth with the beginning step.
The beginning step? Okay. So we took 2y plus 12, we plugged it in for x, right? Because it equals x. So I distribute my 2 then. 4y plus 24 plus y equals -1. 4y plus 1y is 5y, plus 24 equals -1. And from there, just algebra. Subtract 24, divide by 5. Okay, does that make sense?
Yeah.
Alright. Bryce just said, I don't like this method. That is perfectly okay. Right? If you would rather solve the second equation for, or excuse me, the first equation for x, or solve them both for y, and do equivalent forms, do it that way. Find which method you're comfortable with and make it work. Right? The substitution is going to be a little bit quicker than equivalent forms because you don't have to solve anything out for it. But you can use that method. We're not telling you have to do certain ways, guys. Find what's best for you and do it that way, okay? Cool?
Yep.
Sweet. Homework time.
Yay.
Subscribe, swipe up.